Okay, 6.9, water wheels in the unit circle. This is going to be our last lesson of Module 6 and just kind of wrap up the work that we've done on unit circle with radians. Water wheels were used to power flour mills before electricity was available to run the machinery. The water wheel turned as a stream of water and pushed against the paddles of the wheel. Consequently, unlike Ferris wheels that have their centers above the ground, the center of the water wheel might be placed at ground level. So the lower half of the wheel would be immersed in a stream. The following diagrams show the potential designs for a water wheel. Each of the 12 spokes of the water wheel will measure 1 meter. In addition to the spokes, the designer wants to add braces to provide additional strength. Two potential placements for braces are shown in the diagrams. The braces and the spoke to which they are attached form a right angle. Find the measure of BAC and ABC in each diagram. Why don't we just do these one at a time? So we'll start there with bullet point number 1. So BAC would be this little angle right here. And we know that our water wheel is divided up into a whole bunch of congruent triangles. How many congruent triangles? Well, this one over here, actually both of them, have 12 equal sections. Okay, so they each have 12 equal sections or triangles. So if a circle has 360 degrees, then I would know that the angle here is 30 because I would go 360 divided by 12. And that lets me know that each one of those angles is 30 degrees. Now, we did BAC. Now let's do ABC. So angle ABC in each diagram, ABC, that would be this angle up here. Okay, so I don't know. I know this is 90, and I know that each of these are 30, but I don't know anything straight off about this, so let's do that last. Well, if the two at the bottom are both 30, that means this entire angle here is 60 degrees. So, since each triangle is 180 degrees, that angle at the top must also be 30 by that reasoning. So we have now found both of the angles that they ask for in bullet point 1. Now let's go ahead and move on to the second bullet point. Okay. Find the exact lengths of AB, AC, and BC, not just decimal approximations. Explain how you found these lengths exactly. Okay. So let's take those one at a time. So let's do AB. Well, it tells us here that each of the 12 spokes of the water wheel measures 1 meter. So this has a radius of 1. Okay, now let's take a look at AC. So AC is the distance along the x-axis. Now you might think that that's 1, but it stops short, right? It stops right there. So it's going to be a little bit less than 1. All right, but I do know that the hypotenuse, what do we know? I know the hypotenuse is 1, and I know that this is a 30, 60, 90 triangle. So, by the properties of a 30, 60, 90, I know that the short leg is half the hypotenuse. So BC I actually did before AC here. And then I know that AC is the short leg times the square root of 3. So here's my short leg times the square root of 3. You might think of it as that, which gives me the square root of 3 over 2. Okay, so that let me find the parts that we needed to know there. And then you'll see on the second brace, when the triangle is a little bit different, it's the same triangle, just oriented differently. But this is now the 1/2, this is the 1, and this is the square root of 3 over 2. Okay, label the exact coordinates of B. Okay, I'll do that in a different color. They already have green on there. How about my bright blue? Here's B. So the question is, what ordered pair is that? Well, it's the square root of 3 over 2 to the right and 1/2 up by what we just talked about. And then this b is the exact opposite. On this b, we're going 1/2 over and the square root of 3 over 2 up. Okay, and label the coordinates b in each diagram. The exact coordinates of b. Okay, we did that. Okay, so that is number 1. Okay, moving on to number 2. Based on your work above, label the exact values of the x and y coordinates for each point on the following schematic drawing of the water wheel. Remember that the center of the wheel is level at the ground, so any points below the center of the wheel should be labeled with negative values. As in the Ferris wheel models, label points to the left, to the left of center with negative coordinates also. Okay, so with the Ferris wheel, everything was above. It was all positive. But with the water wheel, we know that the other part is dipping down below the ground. So anything down here is going to be negative. And they're also saying anytime we go to the left over here in quadrant 2 and quadrant 3, for the x value is also going to be negative. Okay, so what do they want? They said label the exact values. Okay, so we've already done a little bit of this in 1. We know that this right here, remember how it made this little triangle right here, right? That was a 90, and this was 30 and everything. Well, this was the square root of 3 over 2, comma, 1/2. Okay, and we also found this one. We found out that this one was the opposite, that it was 1/2 over and the square root of 3 over 2 up. And this point we've known how to do forever since you started graphing on a coordinate plane. It's 0 over and 1 up. Okay, now we are finished with quadrant 1 and we've got to start thinking about the other quadrants. So, how are we going to do that? Well, what we're going to do is we need to go left now. So now we're looking at this triangle here. Okay, and we know that the short leg is always 1/2 and the long leg is always the square root of 3 over 2. So this point right here is a negative 1/2 because I'm going left 1/2 and then up the square root of 3 over 2. And then this triangle here is going to be left the square root of 3 over 2 up 1/2. So you just have to decide what's positive and what's negative. This one's easy. This is 1 left and 0 up or down. Okay, now we're done with quadrant 2. Going on to quadrant number 3. So on quadrant number 3, now this is our point down here, and this time we're going, the distance to the left is the long leg, so we're going left the square root of 3 over 2, and we're going down 1/2, so they're both negative. Here we're going to go left 1/2, negative 1/2, down negative square root of 3 over 2. And here we have 0 over and 1 down. And we're just going to keep going. Now we're on to quadrant 4 right here. We're going to go over 1/2 positive, but then we're going to go down the square root of 3 over 2. And then here we're going to go right square root of 3 over 2 and down 1/2. And then our last point is the point 1, 0. This may look a little bit familiar from kind of what we did in Apex. So we now have drawn a good part of the unit circle there for problem number 2, and my video is getting a little long, so I think we'll break here and I'll make another video.